Dear friends, today we are going to talk about the morphology of Lamellibranchia. The majority of the mollusks, for example oysters, whales, cuttlefishes, etc. are all marine, but some live on land while others in fresh water. Unlike the worms and arthropods, they are unsegmented animals and they bear no severely repeated appendages. Typically, the body is bilaterally symmetrical and consequently a repetition of the same organs on each side. But in most gastropods, this symmetry is more or less completely lost. From the dorsal surface arises a fold of the skin forming what is known as the mantle. This generally secretes a calcareous shell consisting of one or two, occasionally more pieces. On the ventral surface of the body is the foot of a muscular organ which is used in locomotion. In most cases, respiration takes place by means of gills which are placed in the cavity enclosed by the mantle. A heart is present and is on the dorsal surface. It consists usually of a ventricle and two auricles. The mouth is situated anteriorly and except in the lamellibranchs is provided with a rasping organ, the odontophore, and in the anus. In typical forms, it is placed posteriorly. Renal organs, for example nephridia, are present and a place of the body cavity in communication with the exterior. The nervous system usually consists of the ring around the esophagus and usually of three main groups of ganglia from which the nerves arises. Only the sexual reproduction occurs. Most forms are unisexual and a few are hermaphrodites. The mollusca are divided into 5 classes. Number 1, Lamellibranchia. Number 2, Amphineura. Number 3, Gastropoda. Number 4, Scaphopoda. And finally, number 5, the Cephalopoda. In the Lamellibranchs, as in the brachiopods also, the shell is generally calcareous and consists of 2 valves. But these, instead of being dorsal and ventral, as in the latter, are placed on one the right, the other on the left side of the body, and the two are joined together by means of a hinge and a ligament at the dorsal margin. The interior of the shell is lined by a fold of the skin, the mantle, which is divided into 2 lobes, one being placed in each valve in the middle of the space enclosed by the mantle, the mantle cavity, and projecting from the ventral surface of the visceral mass is the foot. This is laterally flattened muscular organ, frequently hatchet or plowshare shaped, and is used for crawling or for burrowing in sand or the mud. Sometimes, as in case of the Trigonia, by means of a rapid movement, it enables the animals to jump to a considerable distance. On the posterior part of the foot, there is in some genera, for example Metellus, Pinna, area, a gland which secretes the threads of a viscous substance which gradually harden and then form a bundle of horny fibers known as byssus, by means of which the animal moves itself into the foreign objects. On each side of the foot, between it and the mantle and attached to the body dorsally, are the gills or the branchia. These consist of the filaments which usually become connected so as to form the leaf or plate-like bodies, whence the name Lamellibranchia. In some forms, the margins of the 2 mantle lobes, although in contact, are not united, and when this is the case, there are usually at the posterior margin 2 openings leading from the exterior to the mantle cavity. These are produced by adjoining excavations or the notches in the two lobes of the mantle. A current of the water caused by the cilia on the gills and the mantle flows in through the ventral opening and provides the animal with food and oxygen. Another current flows out through the dorsal opening carrying with it fecal matters. In many cases, however, the two lobes of the mantle are fused at one or more points. This union occurs between the exhalant and inhalant openings and also in many forms below the latter opening. In this way, the mantle becomes a kind of a bag having three openings, a ventral for the protrusion of the foot and the two posterior for the inhalant and exhalant current of the water. Frequently, at the posterior openings, the mantle is greatly produced so as to form two complete tubes known as siphons. The shell cart can be closed by means of the adductor muscles which pass from the interior of one wall to the other. In many genera, there are two adductors and these forms are frequently spoken of as the dimeria, others known as the monomeria. Possesses one adductor only, and when this is the case, it is the posterior which is present. The anterior having atrophied, this occurs in the oyster, but in this and in all other forms, so far as it is known, the interior muscle is present in the young setae or young state. In the Lamellibranchs, there is no head, hence the class is sometimes spoken of as the acephala also. The mouth is in the middle line of the body, ventral to the anterior adductor muscle, and is not provided with the organs of mastication. At each side of the two leaf-like processes, the labial palps, the mouth leads into a short esophagus which passes into a globular stomach. Next is the intestine, which after undergoing many convolutions in the foot reaches to the dorsal surface of the body, where it passes through the pericardium and is surrounded by the ventricle of the heart. The anus is situated dorsally to the posterior adductor muscle. The nervous system usually consists of three pairs of ganglia. One pair is placed at the sides of the mouth and another is connected by nerve cord with a pair of the foot, and with the third pair placed beneath the posterior adductor muscle. From these ganglia, nerves are given off to the muscle, gills, etc. Tactile organs are present on the margin of the mantle and especially on the ventral siphon. In some forms, eyes occur at the ventral margin of the mantle lobes. They are especially well developed in the genus Pecten. The heart is placed dorsally just below the hinge and is surrounded by a large pericardial cavity. It consists of two auricles and a ventricle which, as already mentioned, extends around the intestine. The renal organs consist of a pair of glandular tubes underneath the pericardium. In almost all the cases, the sexes are separate, but a few forms are hermaphrodite also. As already mentioned, the two walls of the shell are on the sides of the animal. The margin near the hinge is dorsal, the opposite where the valves open is ventral, and that near the mouth is anterior. That near and the siphons are posterior. In majority of the cases, the two valves are equal or almost equal in size, and each valve is generally in equilateral. But in some forms, for example Glycymeris, the cell is nearly equilateral, and in others, for example Ostrea, it is inequivalent. When the shell is in equilateral, the direction of the greatest growth is perpendicular to the hinge line. When the inequilateral, the direction is oblique to the hinge line. Each valve may be regarded as greatly depressed hollow cone, the apex of which forms the umbo. These umbones are sometimes straight, for example Pecten, but generally curved towards the anterior margin in a few genera, for example Nucula, Trigonia, Exogara, etc. They are directed posteriorly. In Diceras, they are spiral. Sometimes there is in front of the umbones and bounded by a groove an oval depressed area, half being on each valve. This is termed as the lunule. Behind the umbones, there may be a somewhat similar but larger area is present, which is known as the eustachian. In the interior of the walls, various markings produced by the union of the muscles with the shell may be noticed. The adductors form oval, round, or sometimes elongated depressions in the dime area. There are two in each wall, one being near the anterior border, the other near the posterior. In the monomaria, the single adductor impression is usually near the middle of the wall, when, as in the genus Maya, the two muscles are placed at equal distances from the hinge margin. They are of nearly the same size, since on account of their position, they are equally efficient in closing the walls. But in forms like Mytilus, where the shell is very inequilateral and the anterior muscle is close to the umbo, but the posterior at the considerable distance from it. For the same reason, the single muscle of the monomaria is attached near the center of the wall. Less important than the adductor impressions are those produced by the muscles for the movement of the foot, protractors and retractors. These occur close to the anterior and posterior adductors. Passing from one adductor impressions to the other in each wall is a linear depression caused by the attachment of the muscle of the mantle to the shell, and known as the pallial line. In some forms, this line runs evenly between the two adductor impressions and parallel with the margin of the wall. It is then said to be simple or entire. But in those genera which possesses retractile siphons, the pallial line bends inwards just before reaching the posterior adductor. This indentation is known as the pallial sinus and is caused by the bending inwards of the part of the pallial muscles which serve for the retraction of the siphons. The hinge is formed by the projections known as teeth, which in the two walls, the teeth of the one wall fitting into the depressions between those of the other. Its function is to ensure that the wall should close perfectly. The margin of the wall on which the teeth occur is known as the hinge line. Generally, it is curved, but in some cases, it is straight also. For example, area. Several types of hinges may be recognized. Number 1, taxodont, where the teeth are numerous and more or less similar in form and size. For example, the cula. Number 2, the disodont. The teeth are of simple type and are developed from the internal ribs at the margin of the wall. The hinge margin may be simple or somewhat thickened. For example, Mytilus. The disodont hinge appears to have been derived from the taxodont forms in which the teeth radiate outwards from the umbo. Number 3, isodont. There are strong teeth of equal size which fit into the corresponding sockets into the another wall. The teeth are placed symmetrically on each side of the median ligament pit. For example, spondylus. And number 4, the schizodont. The teeth are few in number, thick, and some fine grooves. A typical form is trigonia, in which a teeth diverges from below the umbo, and the middle tooth of the left wall is bifid. In others, for example, unio, the teeth are less definite in shape and position. Number 5 is heterodont. The teeth are few in number and not all of the uniform shape and size. They are divisible into those, usually 2 or 3, which are placed immediately under the umbo and are known as the cardinal teeth, and others termed as laterals, which are in front of and behind the umbo, forming the anterior and the posterior laterals respectively. Some or all of the cardinals or of the laterals may be absent. The hinge margins is extended as a vertical lamina or flange known as the hinge plate on which the teeth are born. For example, Meritrix. Number 6 is desmodont. True teeth and a hinge plate are absent, but one or more lamina or ridges are developed at the hinge margin. For example, Pleuromia. In some genera in which the hinge line is straight, for example area, there is between the hinge line and the umbo of each valve a flattened triangular part of the shell known as the area. When this is present, the umbones of the two valves are of course widely separated. The areas due to the more extensive growth at the hinge margin then occurs in the genera in which the umbones are close together. The lunule and eustachian appears to represent the anterior and the posterior parts of the area. Some Lamellibranchs with a straight hinge line, for example pecten, have on other side of the umbo triangular or wing-like extensions of the shell known as the ears. In the brachiopods, the valves are opened by divaricator muscles, but in the Lamellibranchs, the work of these muscles is performed by the ligament. This consists of two parts, the external and the internal, sometimes erroneously termed as the cartilage. One or the other may be absent. The external ligament is composed of the horny material. It is placed at the hinge margin, usually posterior to the umbones, and is frequently attached to more or less prominent ridges. In some genera, for example Glacimaris, the external ligament extends both in front of and behind the umbones. The internal ligament consists of parallel elastic fibers and is placed in a hollow or pit on the hinge plate so that when the valves are closed, it is compressed, and being elastic tends to force the valves apart. Its action is similar to that of a piece of Indian rubber placed in the hinge line of the door. The external ligament acts like a C-spring and is bent when the valves are closed. Consequently, in order to open the shell, the animal has merely to relax its adductor muscles. Occasionally, the ligament is preserved in the fossil specimens. The length of the Lamellibranch shell is measured from the anterior to the posterior margin, the breadth or the height from the umbo to the ventral margin, the thickness from one valve to the other at right angles to the lines of length and breadth. The shell is secreted by the mantle. Its structure varies in different groups. These layers may be distinguished into: number 1, on the external surface is a green or brownish layer formed of horny material, what you call as the conchiolin, and known as the periostracum, frequently referred to as the epidermis. This layer is not usually preserved in the fossils. Number 2, in the middle is the prismatic layer consisting of prisms, usually of calcite, each being encased in a sheath of organic material. The prisms are often arranged more or less perpendicularly to the surface of the shell. The inner layer consists of the aragonite and may be formed of a very thin lamella separating by thin layers of organic material when it is pearly or nacreous, or it may be formed of thicker lamella when it becomes porcelaneous. The chief genera in which this layer is arenaceous are Nucula, or nacreous are Nucula, Pteria and Perna, Trigonia and Junia also. The prismatic layer is formed by the margin of the mantle only, the pearly layer by the general surface of the mantle, and this layer gradually encroach on the former, which consequently cannot afterwards increase in thickness, whereas the pearly layer may do so throughout the life of the animal. The surface of the shell may be smooth or may be ornamented with radiating or concentric ribs and stria, or with tubercles or spines also. Often the exterior surface shows the concentric lamella, which represents the periods of growth. The part of the shell at the umbo is that which was first formed and often differs in the ornamentation and form from one another parts. The margins of the valves may be smooth or crenulated. Sometimes, as in some species of pecten, the entire shell is corrugated, thus increasing its strength without materially adding to the weight. In many genera, the two valves can be completely closed In others, they are always open at some part and are then said to be gaping. This gape occurs most frequently at the posterior end and serves for the passage of the siphons. Sometimes there is also an anterior gape through which the foot or byssus passes into the exterior, sometimes a smaller embryonic shell known as the prodissoconch, and is found at the umbo of the adult shell. This represents the protegulum of the brachiopods and the protoconch of the gastropods and cephalopods. When the soft parts of the animal are present, this is easily done, but when the shell is only before the observer, the points to be noticed are the following. Number 1, the umbones are generally directed anteriorly, and in equilateral shells, the posterior part of the valves is, with only a few exceptions, nucula, lima and donax, longer than the anterior part. Number 2, the lunule is anterior to the umbones. Number 3, the external ligament is commonly posterior or to the umbones and is never entirely in front of them. Number 4, the pallial sinus is posterior. Number 5, when one adductor impression only is present, it is the posterior. Number 6, when one adductor impression is distinctly larger than the other, the larger is the posterior. Having found the anterior and posterior margins, the shell should be placed with the dorsal surface uppermost and the anterior margin pointing away from the observer. Then the right and left valves will be on his right and left hand sides, respectively. Most of the Lamellibranchs are free and can move by means of the foot. Since these live with the median plane of the body in a vertical position, the two valves are of equal size. A few genera, for example Pecten, Lima, move by the rapid dosing of the valves, which causes water to be forcibly expelled from the mantle cavity. Some forms, for example Pecten, reset on the one valve, which then becomes more convex than the upper valve. Others, such as the oyster, are permanently attached by one valve, which has been secreted by the mantle directly onto a rock or some other objects to which it adheres firmly. In some cases, the right valve is fixed, in others the left. The shell in these forms becomes irregular and the fixed valve is larger, more convex and thicker than the free valve. Other genera, for example Pteria, are attached by means of a byssus which often passes out through a notch or sinus in the margin of one or both valves. Such forms tends to become inequilateral. Many genera burrow in the sediment on the seafloor and live with the posterior and uppermost. The valves are elongated posteriorly so that the shell becomes distinctly inequilateral and the line joining the two adductor muscles is parallel with the dorsal margin of the valves. Since these Lamellibranchs are sufficiently protected in their burrows, there is no necessity for the complete closing of the valves, and there is a gap in the posterior end of the siphons and often another anteriorly for the food. As frequent opening and closing of the valves is not needed, the hinge tends to become degenerate. In order to facilitate movements through the sediment, these burrowing forms often have laterally compressed valves with a smooth surface. A few genera are capable of making burrowings into the various substances in the set that the shell tends to become cylindrical in form. Thus, Teredo, the shipworm, bores into wood, Lithophaga and Saxivantho, limestones and pholas into various materials such as sandstone, limestone, peat and amber. Wood perforated by Teredo has been found in fossil in various formations of the Eocene and Oligocene age. The features which more especially characterize the Lamellibranchs as a class are the absence of a head and of organs of mastication, the bilateral symmetry, the division of the mantle into two lobes, the bivalve shell, and the lamellar gills. Although at first sight the shell appears to resemble closely that of the brachiopods, it differs in several important respects. Number 1, the valves are right and left instead of dorsal and ventral. Number 2, they are generally inequilateral and equivalve. Teeth occurs on both valves. Number 4, a ligament is present. Number 5, the umbones are never perforated for the appenduncle. Number 6, the microscopic structure of the shell is different. The classification adopted here is based primarily on the character of the hinge, but with other features taken into account. The three main divisions are Taxodonta, Anisomeria, and Lamellibranchia. Thank you very much.